Welcome back everybody for another lesson in geometry. I'm Mr. Waranga, and today I'm going to be talking about the difference between expressions and equations. Now going forward into the next part of Unit 2 in geometry, we're going to be seeing a lot of equations that are going to be set up. In order to solve the equations and solve for the variables that we're looking for, we need to know the difference between an expression and an equation and what we can do and what we can't do with these. So first of all, we're going to start talking about what an expression is. Now you've seen so many different expressions in math. An expression is a statement that contains numbers, variables, and or operations. So when we talk about numbers, that can be any kind of number. It can be just whole numbers, it can be fractions, it can even be special numbers like pi, where we use symbols to represent a number. For example, pi, which you have seen before. It can contain variables, which we normally use letters. We normally use X and Y, the most common ones, but they can also be different types of letters. We can use A, B, C, and sometimes you'll see, even later on in geometry, we'll even use some Greek letters. And then we have operations. Operations are what we do to those numbers and what we do to those variables. That includes addition, subtraction, multiplication, division, exponents, and square roots. One of the most important things about an expression that sets it apart from an equation is that there's no equal sign. An expression does not have an equal sign. What we can do with expressions is we can simplify them. So you've heard many times to simplify something, that means we're dealing with expressions. For example, when we looked at fractions in the last unit, if we had the fraction 3 over 6, that's an expression of this fraction, and it can be simplified by reducing the fraction to its simplest form. So I can reduce this to 1/2, because both the top and the bottom are divisible by 3. If I do 3 divided by 3, I get to 1. If I do 6 divided by 3, I get to 2. So I can simplify expressions to get them in a simpler form. Here are some examples of different expressions. You could have just a single number, like the number 6. That's an expression. You can have just a variable, x. That's an expression. You can also have a combination of variables and numbers using operations. X plus 2, that's the variable x, the operation of addition, and the number 2. This is an expression. And we can also have more than one operation. We can have an expression like this, 2x minus 3. This is the number 2, the variable x, and the operation of multiplication between them, the operation of subtraction, and then the number 3. So it's just some combination of numbers, variables, and operations to get an expression, and no equal sign. The other thing we're looking at are equations. So equations contain two equal expressions, and we use an equal sign in between two expressions to show that they are equal. When we're dealing with equations, what we can do with them is that they can be solved. We can solve equations. Expressions we can simplify, and equations we can solve. Now, in this example of an equation, you'll see we have 4x plus 5 equals 2x minus 3. And if you notice, on either side of the equal sign, we have expressions. So on the left side of the equal sign, we have the expression 4x plus 5. This is the combination of the number 4 with the operation of multiplication with the variable x, the operation of addition with the number of 5. It's a combination of numbers, variables, and operations. That's an expression. On the other side, we have another expression, 2 being multiplied with the variable x, and then subtracting the number 3. When we say that these two are equal, that's when we get an equation. The whole thing is an equation. Some other examples of some equations are listed over here. We have the expression, which is just the number 3, and we have equals the expression 2 plus 1. Now this is something important, because if I were to write 3 equals, let's say 2 plus 2, Now this is not an equation because it's not true. 3 does not equal 2 plus 2. This is not an equation. We cannot say that. This is invalid. So the thing about equations is that both sides of the equal sign have to be equal to each other in order for it to be a valid equation. So this one works because 3 is equal to 2 plus 1. And these two expressions are equal. This next one, we have the variable x equals 5. A lot of times when we're solving equations, this is what the final step looks like. We can also have equations that are unsolved, like this one here. We have the expression 2x plus 55, and we have the expression 180. Now, we can solve this equation, which is what we're going to talk more about on Thursday. But just to start off, this is what it would look like. And we can have another expression like 4x plus 5, which is not simplified, and we're going to get to that in a second, but it's still an expression. 4x plus 5 equals the expression 90. Now, when we talked about expressions and equations, we talked about the difference between simplifying and solving. So I'm going to go a little bit more in detail about that. Simplifying is what we do to expressions. The way that we simplify expressions is by combining like terms. Now, you've probably heard this before, and you've probably done this plenty of times in Algebra 1, but I'm going to kind of review it and talk about it a little bit more. First thing you need to know, what does like terms mean? Like terms are the parts that are being added, and they have the same variable with the same exponent. So in this example, each piece that's being added, every time there's an addition or subtraction sign, it separates each term. So 4x is going to be one term, 2 is another term, 3x is a term, x is a term, 5 is a term, and 10 is a term. Now, when you have subtraction, that still counts, even though it says being added, because subtracting a number is the same thing as adding a negative. So I could rewrite this, instead of saying minus 3x, I could write this as plus negative 3x. Instead of writing minus 5, I can write this as plus negative 5. So these are still different terms. When we say combining like terms, we mean adding all the terms that have the same variable with the same exponent. So in this equation, this is a linear equation because we only have x's with no exponent. We can also write this as x to the first power, but that's a little bit redundant and it's not necessary to write the 1 there. It means the same thing. If there's no exponent, it means it has an exponent of 1. So when we combine like terms here, we want to take all of our terms with an x and combine them together. Take all of our terms without an x, which are called the constants, and we want to combine them. So we have a 4x, we have a negative 3x, and we have a positive x. There's no coefficient written there, so we can think of that as 1x. You do not need to write the 1 because it's redundant. It means the same thing. So when we combine these, we have 4, negative 3, and a positive 1. 4, negative 3, and positive 1, when you add those together, you get a total of 2 x's. So we're combining those three terms into 1 to get 2 x's. Then we have our constants. We have a positive 2, a negative 5, and a positive 10. When we combine those together, we end up with positive 7. So simplifying this expression, we end up with 2x plus 7. To put simplifying expressions into context with how you probably see it in geometry, I set up this problem. Now the problem is telling me that angle A and angle B add up to 180 degrees. So we talked about how angles are a degree of rotation, and if we're talking about their angles when we add them together, they're going to add up to 180 degrees of rotation. Now, it's also telling us that angle A is represented by the expression 2x plus 15. So this expression right here represents angle A's measure. If we were to find out what x is, we could figure out how many degrees angle A would be. Angle B is represented by the expression 4x plus 22. Now, if we know that these two angles add up to 180 degrees, I could write an equation that represents the problem. So I know angle A, I'm going to write it like this first. Angle A plus angle B is going to equal 180 degrees. That's what the problem is telling me. Now I'm going to substitute angle A and angle B with the expressions that represent them. So for angle A, I'm going to write the expression 2x plus 15. Because this expression represents angle A. That's what it says up here. Angle B is represented by the expression 4x plus 22 equals 180. Now, in order to solve this equation, if we want to figure out what x is, first we have to simplify the expression on the left side of the equal sign. So this is something that's really important in geometry. We're going to see a lot of problems that are set up like this. It's important to know that when you have an equal sign, anything that you do on one side of the equal sign can only be simplifying. There's no equal signs on this left side, so we cannot use any of the techniques that we use for solving, which we're going to talk about on Thursday. So all we can do is what we've talked about in simplifying, which is combining like terms. So if I look at this expression, 2x plus 15 plus 4x plus 22, I can simplify this by combining like terms. Because they are on the same side of the equal sign, it's a part of an expression, which means all we can do is simplify. If I look, I have the terms 2x and 4x, which I can combine to become 6x. Then I have the constants 15 and 22, which I can combine to make 37. Everything else stays the same on the equation. Now, since both sides of the equation are simplified to the most simple version, all the terms have been combined, then we can solve this equation, which we will talk about on Thursday more in depth than what you've probably seen before.